ಏನಕ್ಕೆ ಸುಮ್ಮನೆ ಕೊಡ್ತೀರಪ್ಪ. Note down. The simply supported beam shown in figure
Sir, green is not usual, sir.
Okay. ಇವೆಲ್ಲ ಗೊತ್ತಾಕೋ ಪಟಕ್ನ ಬೇರೆ ಏನು ಕೇಳಿದ್ರೆ ಆನ್ಸರ್ ಮಾಡೋಕೆ ಭಾಳ ಕಠಿಣ ಆಗುತ್ತಲ್ಲ. ದನ ಕಾಯಾರೆ. Now visible?
No, sir.
Yes, sir.
Okay. Okay. The simply supported beam shown in figure carries two concentrated load loads and a uniformly distributed load draw the SFD and BMD. Draw the SFD and BMD. You note this diagram. Note on this diagram.
Completed.
Noted?
Yes, sir.
Okay. So now you need to find out first reaction forces here. You need to find out first reaction forces. So can you calculate what is the reaction force at A and B? Can you calculate what is the reaction force at A and B? So once you go to the reaction force, okay, once you go to the reaction force, then you can easily calculate all other parameters. Now,
Distance not given. Sir,
distance not given. Good. So ಎಲ್ಲ ಎರರ್ ಐಡೆಂಟಿಫೈ ಮಾಡತ್ತೀರ ಅಂದಂಗೆ ಆಯ್ತು ಈಗ. Okay. Okay. So first you find out what are the reaction forces. First you find out what are the reaction forces. So now taking moment about A, okay, so and equating it to 0 for equilibrium condition. So let us find out what are the moments we are going to get. So 2 into 30 kilonewton, okay, which is acting in a downward direction. Let us go for this as an hogging. Now 20 into 4, okay, 20 into 4, this is also in hogging direction, minus. So now this UDL has to be converted in terms of point load. So to convert this UDL into point load, so let us go for draw the diagram here, conversion of UDL into point load. Now this is what a 10 kilometer Newton per meter, okay. So if you multiply here, how much you are going to get? 10 into 40, so 10 into 4 is a 40 kilometer is a point load. Position is exactly at the middle, exactly at the middle. Now this is what a 2 meter, this is what a 2 meter, okay. Next, so what is the position? Now it is exactly middle, 2 meter. Now this is what a point C. Now prior to this one, how much distance is there? 4 meter is there. So now let us go for 40 into 6 plus, okay. Now this reaction at point D is causing and sagging moment, okay. This is what RD into 6. This is not a RA, this is RD into 6. So now you find out. So what is the value of RD? Reaction force at D.
Sir, RP into 8 ಆಗುತ್ತೆ.
RD into 8, right? Not a 6, RD into 8. Okay.
$47.5 kilonewtons.
47.5
Kilonewtons.
Okay, everyone got the same answer?
Yes, sir.
Yes, sir.
Okay, now this is sort of 45.7 kilonewton is reaction force at D. So now let us calculate
47, sir. 47.5.
47.5. Okay. Now let us calculate reaction force at A. RA. Now this is equal to sigma F minus RD. Now sigma F, let us go for a down direction, it is a Y. So 30 plus 20 plus 40 minus 47.5. So that is a 42 point, okay, it is a 90. 90 minus 47.5, 42.5 kilonewton. Is it right?
Yes, sir.
Okay. Now let us draw the diagram here. Okay. So that is what a force diagram. Now this is what a RA. acting in upward direction, 42.5 kilonewton. Okay, this is RD acting in upward direction, 47.5 kilonewton. We have a force. Okay, so we have a force. Now 30 kilonewton is on this side, 20 kilonewton is here. This is 10 kilonewton per meter. A possible distances are, sorry, not a possible distance. This is a 4 meter here. This is a 2 meter. This is a 2 meter. Okay. Now let us go for first shear force diagram here. Okay. Let us first go for shear force diagram. This is what better to draw on this side, okay, because you need to draw the diagrams here. So let us first calculate shear force. Okay. So now shear force at A. This is what A, B, C, D. Shear force at A. So now get the shear force at A. Let us consider the section here. Okay. Consider the section. Now how to calculate the shear force? The shear force is summation of the forces including reaction forces either to the left side of the considered section, either to the right of the considered section. So now I have considered on left hand side. Now I have considered on left hand side, right? So now I'll draw the diagram here if you're getting confusion. Okay. Now this is what RA. Now what it is doing? It is doing left side and portion to push up. That means it is moving the left side portion in upward direction. Then it is what reaction force is a positive. Right. Now let us write here. This is how much? 42.5 kilonewton. Okay. Similarly, reaction force at a point B, this is equal to 42.5 kilonewton before consideration of the 30 kilonewton load. Let us make an assumption here. Now this is what RA, okay, pushing it in upward direction. Now it is a position of point B. Let us first imagine, so you don't have a load of 30 kilonewton. Okay. If you don't have a load of 30 kilonewton, then the shear force at B is 42.5 kilonewton. Are you agree with this one? Yes or no?
Yes, sir.
Okay. Now if we add the 30 kilonewton, which is try to push this left side portion in a downward direction. Now this is what a negative, okay, because they try to push in a downward direction. Now let us see here, 42.5 minus 30, you got how much here? 12.5 kilonewton. Okay, right? If you consider 30 kilonewton, you are going to get a 12.5 kilonewton. If you don't consider, you are going to get a 42.5 kilonewton. So why I am giving this one? Because there is a rise in the shear force as you go on adding the loads. As you go on adding the loads. Now let us look out here. Shear force at C. Now shear force at C. Okay. Again, I'll go for the same case here. Now this is what a RA. This is a 30 kilonewton load here. So now you have a section or you have a point C here. Okay. Now what is the total load here? Total load, it remains the same. Okay. Now I'll just add up one more load. It is of 20 kilonewton. Now what is the total load is try to push in down direction is a 50 kilonewton. So what is the load which is try to push in upward direction? It is 42.5. Now already you have, I'll write the complete equation, then you can understand it more easily. Now here 42.5 upward, okay, minus 30 in a downward, minus 20 in downward. Now calculate how much you are going to get. You are going to get a minus 7.5 kilonewton. You are going to get a minus 7.5 kilonewton. Yes or no?
Yes, sir.
Okay. Next, shear force at D. Shear force at D. Now you have a UDL between point C and D, okay, between point C and D. Then the variation of the shear force is of a linear nature. So minus 7.5 kilonewton, okay, minus 7.5 minus 10 into 4 minus 47.5 kilonewton. You got it? Now variation is linear here. Suppose if you take a only 1 meter span here, okay, so 1 meter span you are going to get a different load share. So you are going to get a minus 17.5 first, then minus 27.5, then minus 37.5 kilometers. Right? Now look out. Now we'll draw the shear force diagram. So what is the shear force at A? It is a 42.5 kilonewton. Okay, let us go for this is a point 42.5. This load remains the same up to point B. Okay. Now you are adding a downward load of how much? 30 kilonewton. So now you got here 12.5 kilonewton. Here you got a 42.5 kilonewton. Next, this load remains the same here. This load remains the same. Okay. Now you are adding again 20 kilonewton. So there is try to push in downward direction. Okay. Now how much you are going to get here? Minus 7.5. Now as you have UDL, it's going to vary linearly. It's going to vary linearly. Let us check here. Suppose now I have one point here, E point, which is at a distance of 1 meter. Now UDL is how much? You are going to calculate minus 7.5. Minus is moving in the downward direction, 1 into 10 minus 17.5 kilometer. You are going to get a minus 17.5, 27.5, 37.5. Next you are at right 47.5. Now this is what the shear force diagram, right? So this is called a SFD. Okay, this is what a force diagram or free body diagram, okay, or space diagram. You got how to calculate shear force. So next we'll go for bending moment. So now for calculation of bending moment, you can write the equations considering any one support here. Considering any one support. So let us go for the diagram once again here. Okay. RA, RD, point load, then UDL. This is 10 kilonewton per meter. This is 4 meter. This is 2 meter. This is also 2 meter. This is point A, B, C, D. Right. Now let us consider a section, okay, at a distance of X from left support. From left support. Right. Now you need to find out bending moment there. You need to find out bending moment. Let us see. So now this is 30 kilonewton. This is 10 kilonewton. So 30 into x minus 2. You just check out. I am writing equation. Minus 10 into x minus 4.
Sir,
Ah,
sir, 20, sir.
this one is 20. Right. 20 into x minus 4. Okay. Minus 10 into x minus 4. Okay. Into x minus 4 by 2. Whether this equation is right or wrong? Whether this equation is right or wrong?
Sir, 40 into above.
ನಾನೇನಿದ್ದೀನಿ ಬರೋದ equation ಕರೆಕ್ಟು ತಪ್ಪು? Think ಮಾಡ್ರಿ 2 ನಿಮಿಷ. Just think it. Whether the written equation is right or wrong. Whether it is right or wrong? Hello? I am intentionally written it is wrong. I am intentionally written it wrong. Where I made a mistake, you just check it.
Sir, the 10 into x minus 6 ಆಗುತ್ತೆ
10 into ಹೇಳು
x
ಥಿಂಕ್
minus
ಮಾಡು.
6 ಆಗುತ್ತೆ
6 ಆಗ್ಬೇಕಂದ್ರೆ ನನ್ನ ಕೇಳಿದ್ರೆ ನಾನು ಹೇಳವ.
10 into 4.
10 into 4 ಮತ್ತೆ
Sir, sign convention.
sign convention. Next. ಮತ್ತೆ ಥಿಂಕ್ ಮಾಡ್ರಿ, ಹೆಂಗೆ ಬರೀತೀರಿ? ಮೊಮೆಂಟಮ್ ಇಕ್ವೇಷನ್ಸ್ ಹೆಂಗೆ ಬರೀತೀರಿ? ಸೇಮ್ ಇಕ್ವೇಷನ್ಸ್ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟಿಗೆ ಯೂಸ್ ಮಾಡ್ತೀರಿ, ಹೌದಾ? ಹೌದಿಲ್ಲ? ಹೌದಲ್ಲ? ರಿಯಾಕ್ಷನ್ಸ್ ಫೋರ್ಸ್ ಕಂಡುಹಿಡಬೇಕಾದ್ರೆ ಹೆಂಗೆ ಬರೆದ್ರೆ ಇಕ್ವೇಷನ್ ಅದೇ ರೀತಿ ಇಲ್ಲಿ ಬರಿಬೇಕು, ಹೌದಾ? ಲೆಟ್ ಅಸ್ ಸೀ what are written here. Bending moment at section xx, right? But when I say bending moment about xx, you must include the effect of reaction forces also, and sign conventions are to be taken from the reference of section xx. But in this case I now took a sign convention from reference xx, okay? But I took sign convention from point A. It is what are wrong. It's what a wrong, right? So now let us look out here. Now I will draw the diagram here. You just carefully watch. Okay. Now this is the section xx. Okay. Now you have a reaction RA. Now this is what 30 kilonewton. Okay. This is 20 kilonewton. So it is have a UDL of 10 kilonewton per meter. Now this is the distance of x. Okay. This is the distance of x. Now are you agree? Distance of x, right? Now distance between RA is 42.5. Distance between A and B is 2 meter. B and C is 2 meter. Okay. So we don't know how much distance it has here. Okay. So now this distance is what? X minus 4. Okay. this distance is x minus 2. Okay, now this distance is what? Exactly x. Exactly x. You got a distance calculations? You got a distance calculations from the section xx. Now you are finding out the bending moment at this point. Let us take this point as a q. Okay, now you are finding bending moment at point q, right? Now which is at a distance of x. Okay, which is at a distance of x from left support. Okay. Now what is the effect of RA? So RA try to make this as a sagging moment. This is a sagging moment. Okay, let us look here. Now this is what RA into x is a sagging moment. Next, 30 kilonewton is there, which is try to make a hogging moment. Which is try to make a hogging moment. Okay, now this is what a minus 30 into how much distance you want to remove? You want to remove minus 2 distance. Okay, this is what x minus 2. X minus 2. Next, minus. If I have one more load here, 20 kilonewton. This is what? Minus 20. That is also try to make this hogging moment. Okay, minus 20 into x minus 4. Right? Now you have another UDL for the portion of x minus 4. Now let us convert this x minus 4, okay, into 10 as a point load. Okay, otherwise you first write a distance. The better practice, you need to write first force value, then you need to go for distance value. Now this is what? 10 into x minus 4. It's what? UDL converted into point load. Now x minus 4 divided by 2 is the location of point load. Is the location of point load. Now you got equation. I will rewrite here once again. RA into x minus 30 into x minus 2. Okay, minus 20 into x minus 4. Okay, minus 10 into x minus 4 into x minus 4 by 2. Let us take an example. Now I have a section PP here. Okay, I have a section PP. Now which load is covering at section PP here? The only reaction force is covering. Let us take, I have a section PP which is at a location of 1 meter from left support. Now you need to consider only this portion. You need to neglect all these terms. Okay. Similarly, if you want to find out at a B, okay, you can need to consider this portion. You need to consider this portion. Just beyond the point B, you can just take beyond point B. Even though if you gone for at point B, if you substitute 2 here, 2 minus 2, you will become 0. This term is going to get a cancel. This term is going to get a cancel. Okay. Now let us go for solutions here. Let us go for solutions. Now bending moment at point A, this is going to be 0. Okay, because let us see here. If you substitute x equal to 0 for SF at D, sorry, SF at A, that is what Rx, Ra into x. Ra is how much? 42.5. If you substitute 0, you got a 0 kilonewton meter. Agree? Next, bending moment at point B. Okay, at point B. That is what? X equal to 2 meter. X equal to 2 meter. Is it right? So what is the distance now here? You are going to get a distance x as 2. So what is the equation? Ra into x, okay, minus 30 into x minus 2. Now we substitute 42.5 into x is 2 minus 30, 2 minus 2, this term get cancels. You are going to get 85 kilonewton meter as the bending moment. Okay, that is what at point B. Right. Now let us go for a bending moment at point C. That is x equal to 4 meter. Okay. So what is the equation here? RA into x minus 30 x minus 2. Okay. Minus x minus it's a 20 kilonewton is there. Minus 20 into x minus 4. Right. Now let us substitute x equal to 4 meter. X equal to 4 meter. RA is 42.5. X is 4 minus 30. 4 minus 2 minus 20. 4 minus 4. Okay. Now this term will get cancelled here. Now how much you are going to get to find out?
110.
20%.
How much?
110, sir.
110, sir.
110.
110 kilonewton meter. Right. Now up to point C, bending moment variation is a linear because force into distance only two term here. Okay. But for UDL, so the variation of bending moment is a parabolic because you are going to get x into x by 2. Load, distance, distance. Right. Variation is square here. Right. Now let us find out one point. Now I'll take one point here. Let us take one point, okay, which is 3 meter from D support. Okay. Then x equal to how much? 5 meter. Right? X equal to 5 meter. Let us write here. Bending moment at point Q. Okay. That is x equal to 5 meter. Now what is the relation here? Equation is 42.5. I'll write first equation. Now if we get familiar with the equations, now we can directly calculate, no need of writing equation again and again. RA into x minus 30 x minus 2 minus 20 x minus 4, okay, minus 10 x minus 4 x minus 4 by 2. Okay. Now let us substitute x equal to 5. RA is 42.5, x is 5 minus 30, 5 minus 2 minus 20, 5 minus 4 minus 10, 5 minus 4, 5 minus 4 by 2. Now we calculate. This 5 minus 4, not a 5 plus 4.
97.5 kilonewton, sir.
97.5
5 kilonewton.
Newton meter. Now similarly calculate bending moment. At a point P, let us take x equal to 6 meter. We quickly calculate.
Seventy-five,
75,
sir.
25, sir.
75 kilonewton meter, right? You just grab all the values. Okay, I'll draw the bending moment diagram. Okay, so here bending moment at B is how much? 85. Okay, bending moment at C is how much? 110. Bending moment at Q 97.5. Bending moment at, let us take a point P. Now what is the bending moment at point D? You should get a 0. You just check it. Now we'll write here 42.5 into 8. Okay, minus 30 into 8 minus 2 minus 20, 8 minus 4 minus 10, 8 minus 4, 8 minus 4 divided by 2. You should get a 0 kilonewton meter. You just cross check.
Yes, sir.
You got a 0?
Yes, sir.
Then solution is 100% correct. Okay, you go for cross checking somewhere, either for shear force or either for bending moment. You should get a bending moment at supports 0 here. At supports BM should be 0. Then solution is right, otherwise wrong. Okay, now we'll go for drawing the bending moment diagram. Now this is A, B, C, D. Now bending moment at D is 85 kilonewton meter. Correct? You give answer because I can't go back again. Okay, this is 110. Okay, somewhere you got a 2 points here. Now 1 point, how much you got? Oh, 97.5, 95, right? Now you got a 2 additional point here. Okay, so that is what a Q point and a P point. Q point you got a 97.5 kilonewton meter, and this point you got a 95 kilonewton meter. Now bending moment
75, sir.
is, look, the bending moment is 75 here. Sorry, okay, 75. This point is 75, P point is 75.
Sir.
Okay. Now this bending moment is a positive. Regarding question and marks for drawing SFD and BMD, you will get minimum question of 12 marks, okay, and maximum of 20 marks. ಒಂದು ಕ್ವೆಶ್ಚನ್ ಕನಿಷ್ಠ ಅಂದರೆ 12 ಮಾರ್ಕ್ಸ್ ಬರ್ತದೆ ಬಿ ಎಮ್ ಡಿ ಮತ್ತು ಎಸ್ ಎಫ್ ಡಿ ಡ್ರಾ ಮಾಡೋದು, ಹೌದಾ? ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಂದರೆ ಒಂದು ಫುಲ್ ಕ್ವೆಶ್ಚನ್ ಬರ್ತದೆ. ಯು ಜಸ್ಟ್ ಮೇಕ್ ಎ ಪ್ರಾಕ್ಟೀಸ್, just make practice, okay? So let us go for one more. A simply supported beam, you note down. A simply supported beam AB of a 6-meter span is loaded as shown in figure. As shown in figure. Full point. Draw the shear force and bending moment diagrams. Whether this thickness is visible, or let us go for more thickness of a pen. ಬರೆದದ್ದು ಭಾಳ ಕಾಣಿಸ್ತದ ಏನ ಬ್ಲರ್ ಕಾಣಿಸ್ತದ? ಹಾಂ, ಕಾಣಿಸ್ತದ? ಏನಂದಲ್ಲ ಯಾರೋ? No, this is 40 kilonewton meter. Okay, this is 80 kilonewton meter. Now distance is, this is 3 meter. This is 1.5 meter. This is 1.5 meter. Okay, so let us go for supports. This is A, B, C, D. Now entire span length is 6 meter. So now this is what a space diagram. This is what a space diagram. Now try to find out what is the reaction at A and reaction at D. If you calculate reaction at A and D as correct, then solution is over. Then solution is over. Now we take a 2 minutes time and find out what is the reaction at A and reaction at D. How much you got? How much you got a reaction force at A?
200 kilonewtons.
RA equal to 200.
200.
Okay. RD. RD.
Zero, sir.
0. One given answer as RA equal to 200 kilonewton and RD equal to 0. Now what about others? ಅವನೊಬ್ಬನೇ ಮಾಡೋದಾ ನೀವು ಮಾಡಲ್ಲ?
Sir, RA is equal to
RD
140.
90, sir.
RD 90. Okay. Next.
Sir, RA is equal to 140.
One more. RA equal to
140.
okay.
RD is equal to minus 160.
RD equal to minus 160.
Uh,
Okay, next. So who is this one? Given RD equal to 90 kilonewton. What about the RA? Hello.
Yes, sir. ಮಾಡಕ್ Sir, 390, sir.
390. Is there anybody calculated? Only 3 members are trying. Rest of you are simply watching a movie. Strength of material movie.
Sir, RD 40 kilonewton, sir.
RD 40 kilonewton. Right. Give answer. RD 40 kilonewton. Next. ಮಾತಾಡಕತ್ತ ಇರ್ಲಪ್ಪ ಹುಡುಗರು ನೀವು. See, if you done proper solution, or if you tried to get the solution, it is good. Because the shear force and bending moment diagram is mainly based on the finding out the finding out the reaction force. If you got reaction forces as 100% correct, then your solution is over. Then is your solution over. Okay. So because if you made a mistakes in calculation of reaction force, so you are going to get a wrong answer, and you are going to get a wrong interpretation of a shear force and bending moment diagram. Okay. Now, who is given RD equal to 40 kilonewton? What about the RA?
Minus 45 kilonewtons.
Minus 45 kilonewton. Okay. So you have a next class?
Yes, sir.
Which one? Okay, just give attendance and log out. Now all the answers what you provided, these answers are wrong. Okay. So let us think over these answers and we'll continue next class. You just give attendance.